Hi everyone, it's Mrs. Bebo. In this video, we're going to continue talking about multiplying rational numbers, specifically looking at examples where we're going to evaluate algebraic expressions, and then I'll have a story problem for you at the end. So taking a look at this slide, it says evaluate 1/2 AB if A is equal to 1 3/7 and B is equal to -4/9. We're going to write our answer in simplest form. So with this question, again, it is all multiplying. The 1/2 AB just means 1/2 times A times B. So we need to plug in our values so that we can see what we're working with. We're going to have 1/2 multiplied by 1 3/7 multiplied by a -4/9. Because we have a negative in this question, and only one negative, this is actually going to end up being a negative answer when we are all done. So that's something that I'm just going to make a note of off to the side here. So with this question, that 1 3/7, we do have to rewrite it as an improper fraction. So we're going to take 7 times 1 plus the 3. So this will be 1/2 multiplied by now 10/7, right? Equivalent to the mixed number form, just now an improper, so we can actually multiply, and then multiplying by the -4/9. So just focusing on our 2 on the left-hand side, we have the 1/2 times 10/7. We can actually do some cross-canceling here. So the 10 can be divided by 2, and that'll turn it into a 5. The 2 can be divided by 2, and that will turn it into a 1. And then we'll have 1 times 5, which is 5, and then 1 times 7, which is 7. And so now that's all that's left. That's going to be multiplied by the -4/9. At this point, we can't do any cross-canceling, so we are just going to multiply our numerators and multiply our denominators. So 5 times -4 is going to be -20. 7 times 9 is going to be 63. And there is our final answer for the question on the left. So same idea with the question on the right. It says to evaluate -3/5 mn if m is equal to -1/7 and n is equal to -1 4/9, right in simplest form. So with this question, we have -3/5 multiplied by m, which is -1/7, multiplied by n, which is -1 4/9. So we have 3 negatives in this case. So if I just focus on these two first, a negative times a negative is going to be a positive. But then multiplying by a negative will now turn that answer into a negative. So this is another question where our answer will be negative. So we can just focus on 2 at a time, again, just like we did on the previous question. So if we just focus on this -3/5 multiplied by -1/7, we can't do any cross-canceling. So we're just going to do 3 times 1, which is 3, and then 5 times 7, which is 35. And then, like we said, this is a positive fraction because we had a negative times a negative. Now, we still have this mixed number here, that -1 4/9, and I'm going to go ahead and rewrite this as an improper fraction because, again, when we multiply with fractions, you can't do that with mixed numbers. They do have to be rewritten as improper fractions. So 9 times 1 plus 4 is going to turn into 13, so this will be -13/9. And then we actually can do some cross-canceling here between the 3 and the 9. So the 3 divided by 3 will turn this into a 1. 9 divided by 3 will turn into a 3. And so we'll have 1 times that -13. That's going to be -13. And then 35 times 3 is going to be 105. And so my final answer is going to be -13/105. All right, so moving into our next slide, so our next set of problems here, we're again multiplying rational numbers. We have these algebraic expressions that we're going to evaluate. They just now are all different forms, right? So we have some decimals and fractions going on in each of these questions. So focusing on the one on the left, it says we're going to evaluate 1/4 xyz if x is equal to 9 1/2, y is equal to -8/10, and z is equal to 2 1/5. It says to write our answer as a decimal. I will start off by saying, though, like, if you want to solve this question using fractions, you are more than welcome to, because you're going to get an equivalent answer just in fraction form. I'm going to follow the instructions, though, that say, okay, yep, write your answer as a decimal. But just know you do have the option on this question to work with fractions instead of decimals. So with that being said, again, we're going to use decimals. So that 1/4, I'm going to go ahead and just rewrite it right now as a quarter, so 0.25, 25 hundredths. We're going to multiply that by x, which is 9 1/2. And then we're going to multiply by y, which is -8/10. And then we're going to multiply by z, which is 2 1/5, and that is the same as 2 2/10. So I have rewritten all of this in decimal form. Now we're just going to go through and start multiplying it out. So we'll just kind of go 2 at a time. So starting with this 25 hundredths times the 9 5/10. So writing my work off on the bottom here, we're going to do 95 times 25. So 5 times 5, 25, 9 times 5 is 45, plus 2 is 47. Add our 0, 2 times 5 is 10. And then 9 times 2 is 18, plus that 1 is going to be 19. So 5, 7, 3, carry the 1, so 2. So we're going to have what looks like 2,375, but we're going to add in 3 decimal places, so it'll be 2 and 375 thousandths. All right, and then I'm going to go ahead and multiply these other 2 together. So this -8/10 multiplied by 2 2/10. So again, writing my work out on the bottom, we're just going to think of this as 22 times 8. So 2 times 8 is 16. 2 times 8 is 16, plus the 1 now is 17. And then we're going to add 2 decimal places back in. So this is going to be multiplying by, again, a negative, because we have a negative times a positive. So that'll be a negative, and then it'll be 1 and 76 hundredths. And then now we have to multiply these 2 together. This is where we're going to have a little bit of work involved. So I'm going to pause the video and then work it out, and then you can see my work once I have that organized on the screen here. All right, so now you can see that I have that worked out. It was quite a bit of work, which is why I actually think this question would have been easier using fractions, but that's besides the point. Working this out, we end up with this 418,000. But again, that's not my final answer, because I do need to add my decimal point back into the problem. So in this problem, we have 5 decimal places total. And so my answer is also going to have 5 decimal places as well. So if I add that back in, it's going to be between that 4 and the 1. And so this final answer ends up being a negative 4 and 18 hundredths. All right, so now with the next question, it says evaluate RST if R is equal to -5 1/10, S is equal to -3 1/8, and Z is equal to -4/5. We're going to write in simplest form, so that's our indication that we need to solve this using fractions. However, again, you could solve this one using decimals. I'm going to go ahead and solve it using fractions though. So writing out this question, we're going to have -5 1/10. So I'm going to go and write this as -5 1/10, right? So as a fraction, -5 1/10, multiplied by this -3 1/8. And then we multiply this one by Z, which again, actually I'm not sure why that says Z, because we need it to be T, and I just caught that that is not the same variable. So I am pretty sure that's a typo, and that is supposed to be a T. Love when that happens. All right, so now that T is equal to -4/5, we're going to go ahead and plug that in. And so there we have our problem, but now rewritten with our actual values. We cannot multiply with mixed numbers, so we do need to rewrite those as improper fractions. So the -5 1/10, 10 times 5 is 50, plus the 1, it's going to be 51, so this will be -51/10. Multiplying that by 8 times 3, which is 24, plus 1, so this will be -25/8. And then that -4/5 is good already, because again, it's already a proper fraction. Now I'm going to start with the 2 fractions on the right side here, because we can actually cross cancel between the 25 and the 5. So 25 divided by 5 will turn this into a 5. And then 5 divided by 5 will turn this one into a 1. And then we can cross cancel between the 8 and the 4. So 8 and 4 can both be divided by 4. So 4 divided by 4 turns into a 1. 8 divided by 4 turns this into a 2. So multiplying those 2 out, let me rewrite my first fraction here. Multiplying those out, we got 5 times 1, so that's going to be a 5. And this is going to end up being a positive because it was a negative times a negative. And then this 2 times 1 is going to be a 2. So that -3 1/8 multiplied by the -4/5 ends up being 5/2. So now here we can actually do some cross canceling again between the 10 and the 5. So those can both be divided by 5, turning this into a 1, and then that 10 into a 2. And so we'll multiply across the top. -51 times 1 is going to be a -51, and then 2 times 2 is going to be 4. And then all we're left with now is rewriting this improper fraction as a mixed number. 4 goes into 51. That's going to be 12 times, because 4 times 12 is 48. And then there are 3 left over, so 3/4 would be the fraction portion of that mixed number. And there's my final answer for that question. All right, so taking a look at our last example, which is going to be a story problem. I've already started the outline for this, but the problem says the sign shows the temperature at Badger, Minnesota at 10 p.m. At 4 a.m., the temperature changed by 2/3 of the current value. What is the final temperature? So step one is we have to figure out what 2/3 of this negative 11.5 is. So that's what it tells us in the image. It says at 10 p.m. it was negative 11.5 degrees Fahrenheit. And then at 4 a.m. it changed, so it dropped by 2/3 of that current value. So what is the final temperature? So first, again, we got to figure out what's 2/3 of negative 11.5. So we're going to rewrite negative 11.5 as a fraction, so negative 11.5, and then we do have to rewrite this as a mixed number if we're going to be multiplying, so negative 23 over 2. Again, I got that by doing 2 times 11, which is 22, plus the 1, 23, and then you keep the denominator. So now working out the math there, we're going to do 2/3 of, so multiplying by negative 23 halves. We can cross cancel between the 2's. So those turn into 1's. And then this will be negative 23 thirds. And so negative 23 thirds, we can rewrite that as 3 goes into 23. That's going to be 7 times, so negative 7, and then 2/3. All right, so now we can go through and figure out the final answer. Now that we know that it changed by this 7 2/3, so negative 7 2/3 is what it dropped. So step one tells us that the temperature dropped negative 7 2/3 degrees Fahrenheit, right? So that is coming from our previous step. So to figure out what the final temperature is, well, we just have to add this amount to that negative 11.5. So we're going to do negative 11.5 plus this negative 7 2/3. And so working with adding rational numbers, we do need a common denominator. So in this case, 6 would be a great one to use. So we'll multiply each of these by 3, multiply each of these by 2. And so you'll have negative 11 and then 3/6 plus negative 7 and 4/6. And then this is going to end up being negative 18 and 7 over 6, which we will rewrite that as negative 19, and then 1/6, and then degrees Fahrenheit would be my final label on that one. And that is how we would work out that story problem. So hopefully that helps you with multiplying rational numbers. Thank you for watching.